Hey there, in this video we are going to start looking at rules of exponents. So we are going to start with what an exponent means when it is negative. So we will start with, for example, a to the negative m right here. When we have a negative exponent, we never want to leave our answer with negative exponent. So we will always change a negative exponent to a positive exponent. So a to the negative m is the same as 1 over a to the m. So we take this base of a and this negative exponent of negative m, and we move that piece down to the bottom of the fraction when it was originally on top. And when we move it to the bottom, that becomes a positive exponent. So to make this negative exponent positive, we move that base and that exponent to the denominator, and it becomes positive. So, for example, looking at a number, 5 to the negative second power, we have a negative exponent, so that negative 2 becomes positive when we move the 5 with the exponent to the denominator. So now it's 1 over 5 squared. And then from there, 5 squared is really 25. So your answer would be 1 over 25. So let's try a couple of examples with this concept. So 2 to the negative fourth power, we wouldn't want to leave it like that. So we're going to rewrite this as a fraction where 2 to the negative fourth is going to move down to the denominator. The denominator will now be 2 to the positive fourth. So the base stays the same. The exponent goes from negative to positive, but we can't leave the top of the fraction open, so we do put a 1 in that spot. Now, because we have a number base with an exponent, and that exponent is now positive, we can go ahead and evaluate just this portion right here. So we're going to still have 1 over, and then 2 to the fourth power. You can memorize your exponents, and for example, 2 to the fourth power is going to be 16. Or if you're not sure what that is, you can always multiply it out, 2 times 2 times 2 times 2. And you can use your associative property and do 2 times 2 is 4, and 4 here, so that's going to be 16. So either way, memorizing, or you can multiply it out and you get 1 over 16. Another example would be with a variable base. So we could have x to the negative 12, which is going to, again, move this base with that exponent below the fraction bar, and it will now be x to the positive 12th. And then we don't leave the top empty, so it will be 1 over x to the 12th. Because this is a variable base and not a number base, we can't actually evaluate x to the 12th power any further than just writing it x to the 12th. So that is your final answer on that one. Now, on number 3, it's a little bit different because we have 4w to the negative fifth. So we technically have two bases here. We have a 4 and we have a w. And notice the only base that has an exponent visible is w to the negative fifth power. The 4 does not have an exponent visible, so technically it has a 1 exponent. But even with that, it is not a negative exponent. And so 4 is going to remain where it's at. But we're going to have to move this w to the negative fifth down to the bottom. So it's going to move down and be w to the positive fifth, but it's not a 1 on top this time because we have a 4 in front that stays where it's at. And so our final answer on this one is 4 over w to the fifth power. Now on number 4, again, we have similar to number 3, we have two bases. We have a 7 and we have a w. I'm sorry, we have a y and a 7. And so with that, we have 7 to the negative second power. And then we have y, again, basically to the first power, just like the 4 was over here with 4w to the negative fifth. It's really like a first power. So the only base that has a negative exponent is the 7. 7 to the negative second power is going to have to move to the denominator. Y is going to stay where it's at. So we will have y to the first power, or just y on top, and then 7 to the positive second power on the bottom. Now, because this is a number base, 7 squared, we can go ahead and evaluate. That's going to be y over 49 because that's 7 times 7. And so y over 49 would be your answer on this one. So in summary, the negative exponent rule is a rule that allows us to turn a negative exponent into a positive exponent. So to do that, remember, we move the base that has the negative exponent. So again, we only move the base with the negative exponent to the other side of the fraction bar. So for example, when we have something like 4y to the negative second, only the y to the negative second moves down, and it becomes 4 over y to the positive second power. So keep the bases the same. Those don't change. Only the exponent that was negative changes to a positive when it moves to the denominator. If we have a numerical base with an exponent, we do want to evaluate that. Okay. And if the fraction were empty in the top, then we would want to go ahead and put a 1 in that spot. And again, just as a quick reminder, only the base with the negative exponent moves. So in this example here, the 4 didn't move because it did not have a negative exponent.